For example 4, we're going to determine the equation of the tangent line to the curve f of x is equal to x to the 4 minus x cubed plus x squared plus 1 at the point of 1, 1. So the first thing is we're going to state, given this, that f prime at x is going to be, using the rules that we've just gone over, 4x to the 3 minus 3x squared plus 2x, and then the constant is just going to be 0. Now, at the point of 1, 1, that means that my slope is going to be 4 times 1 cubed minus 3 times 1 squared plus 2 times 1. And when we plug all that in, I have a slope of 3. When we're determining the tangent line to the curve of this at this exact point, then I'm going to say that my slope is 3 at the point of 1, 1, which means that I'm going to say y minus 1 is equal to the slope of 3, x minus 1, or y minus 1 is equal to 3x minus 3. So y is equal to 3x minus 2, or if I put it in general form, 3x minus y minus 2 is equal to 0. For example 5, given the parabola y is equal to 10x minus x squared minus 16, and it wants us to find the equation of the tangent at the point of 4 and 8. Then first I'm going to find what my slope is by taking in the differential, where I'm going to have 10 minus 2x. I know this occurs where x is equal to 4, which means that my slope is equal to 10 minus 2 times 4, which is going to give me a slope of 2. And then I can do my equation. Y minus 8 is equal to 2 bracket x minus 4, or y minus 8 is equal to 2x minus 8. And when I add 8 to both sides, I get y is equal to 2x, or in general form, 2x minus y is equal to 0. When it says, find the equations of the two tangents that pass through the point of 4 and 12. Then if I was to graph this out, and I have my function y is equal to 10x minus x squared minus 16. And it says find the equation of two tangents that pass through the point of 4 and negative 12. Sorry, 4 and positive 12 up here. And this point is not on the parabola, then I'm going to have a tangent. Sorry, I didn't draw this great. I'm going to have a tangent that comes and hits a point here. And I'm going to have another tangent that comes and hits a point along here. Tangent 1, tangent 2. So the first thing I'm going to do is I'm going to do the slope of the secant, where that's going to tell me m is equal to y2 minus y1 over x2 minus x1. And that's going to give me 10x minus x squared minus 16, and then minus my y value here, so minus 12. Remembering that this is my f of x, and that's going to be divided by x minus 4. So that's going to give me 10x minus x squared minus 28 all over x minus 4. The second thing I know is I know the slope of the tangent is the derivative, which is y prime is equal to 10 minus 2x. Therefore, 10 minus 2x has to equal 10x minus x squared minus 28 over x minus 4, so that the slopes match up. I can say that 10 minus 2x times x minus 4 is going to equal 10x minus x squared minus 28, or 10x minus 40 minus 2x squared plus 8x is going to equal 10x minus x squared minus 28. When I move everything to one side, then I'm going to get x squared minus 8x plus 12 is equal to 0, or x minus 2 times x minus 6 is equal to 0, which means that I have two possibilities here. I have x is equal to 2, or I have x is equal to 6. So y is equal to 10 times 2 minus 2 squared minus 16, which equals 0, and I have the point of 2 and 0. I have y is equal to 10 times 6 minus 6 squared minus 16, which is equal to 18. Sorry, not 18, just 8. And I have the point of 6 and 8. if the slope is equal to 10 minus 2x, then it's going to be 10 minus 2 times 2, which is 6. If my other slope is equal to 10 minus 2x, or 10 minus 2 times 6, then that's going to give me a slope of -2. And then I'm just going to put them in my slope point form. Y minus 0 is equal to 6 bracket x minus 2, or y is equal to 6x minus 12, or 6x minus y minus 12 is equal to 0. For my other possibility, y minus 8 is equal to -2 bracket x minus 6. So y is equal to -2x plus 12 plus 8. Y is equal to -2x plus 20, or 2x plus y minus 20 is equal to 0. And there's my two equations. All right, you go ahead and try.